Colin Brooks, Environmental Science Lab Manager with the Michigan Tech Research Institute. And in this project, we are mapping the extent of Cladophora algae throughout the shallow water regions of the Great Lakes. And the important issue here is that the Cladophora algae is growing a lot more than it used to because light penetrates further due to the invasion of zebra mussels, and zebra and quagga mussels. And so there's a lot more light going in, and the algae is growing, and essentially using satellite imagery, we're able to map all the locations that this green mucky algae grows in the Great Lakes, and we can understand where it might end up on the shoreline and how this might create avian botulism and hypoxic areas. And we are now doing lake-wide maps of the shallow water, about less than 20 meters deep regions of the Great Lakes. And from that, we can understand how much the Cladophora algae might be contributing in terms of biomass and affecting productivity of the Great Lakes as well. And so we are creating this for the lower four Great Lakes, Lakes Michigan, Erie, Superior, and Huron, and Ontario. Fortunately, so far, Cladophora is not a significant issue in Lake Superior. Also, we're able to map the changes in how far light has been penetrating into the Great Lakes. Essentially, what we're seeing here is initially as the water got cleaned up, and later on as more and more invasive mussels came in, the light is penetrating further and creating that habitat where lots of the green Cladophora algae can grow. And now what we're doing is we're going to make this data available for public and scientific use. We're going to work with the Great Lakes Observing System and the NOAA Great Lakes Environmental Research Lab to make this data available, and this will become part of the EPA's assessment methodologies for what's going on in the Great Lakes as through the Great Lakes Restoration Initiative.